Welcome to this explainer. Today, we're diving into something I find absolutely fascinating, and I'm really thrilled you're here for it. We're going to decode the critical SASB standards used to measure corporate water accountability in a seriously resource-intensive sector, the containers and packaging industry. If you're interested in how invisible environmental impacts get translated into hard, measurable financial data, you are definitely in the right place.
Okay, let's kick things off with a bit of a provocative question just to snap things into perspective. Think about the last time you ordered something online. When that package landed on your doorstep, how much water was actually required to manufacture the cardboard box? It's not just a quick splash. It can literally be gallons of water for a single package. We're so used to focusing on the paper or the plastic, right? But water is this hidden engine driving the entire manufacturing process. So here is our roadmap to understand how physical water scarcity becomes a measurable financial risk. We're going to cover 1. The water scarcity challenge, 2. Measuring high-stress water, 3. Evaluating water risks, 4. Tracking regulatory noncompliance, and wrap up with 5. The bottom line. Let's get right into it.
Section 1. The water scarcity challenge. Moving from physical realities to financial risks. To really understand why water management is a big deal here, we have to recognize that containers and packaging plants guzzle massive amounts of water. According to the SASB standard, water is heavily used for raw material processing, process cooling, and generating steam at on-site cogeneration plants. So this isn't just some casual utility, it's a fundamental requirement to keep operations running. And as water scarcity increases globally, this physical reality very quickly morphs into a financial risk. The internationally recognized SASB matrix gives us the exact architecture for tracking those impacts. It specifically highlights water management, requiring both quantitative data, meaning the hard numbers, and a deep narrative analysis. It basically forces companies to take what used to be just a vague sustainability talking point and turn it into standardized, auditable financial disclosure.
Moving right along to Section 2, measuring high-stress water. Let's decode metric RT-CP 140A.1.
Under Metric 140A-1, the focus is purely on the quantitative measurement of water usage. Before a company can mitigate risk, they have to know exactly what they're actually using. But there's a really vital accounting distinction to keep in mind here. Water withdrawn means the total amount taken from sources, whether that's a local river, groundwater, rainwater, or the municipal supply. Water consumed, on the other hand, strictly means water that evaporated during cooling, went physically into the product, or just simply didn't make it back to its original source. Think about it like this. A plant might withdraw 1 million gallons, but actually, say they withdraw 1 million but treat and return 900,000 of those gallons to the same river. Well, their consumption is only 100,000 gallons. That distinction is absolutely paramount for building an accurate risk profile. But here's the thing. Knowing how much water you use isn't enough. You really have to know where you're using it. To identify operational vulnerabilities, companies rely on a critical diagnostic instrument called the WRI Aqueduct tool. It's the World Resources Institute's Water Risk Atlas. The standard requires companies to calculate the exact percentage of their water withdrawn and consumed in areas classified as having high baseline water stress, meaning 40 to 80%, or extremely high stress, which is anything over 80%. Because withdrawing 1,000 cubic meters of water in a rainy valley, totally different ballgame than withdrawing it in a severe drought zone. This tool forces that geographic reality right out into the open.
All right, Section 3, evaluating water risks. Decoding metric RTCP 14A.2.
Now we shift from the hard volume data into the narrative of risk. This is where companies have to explain what those numbers actually mean for their day-to-day operations. They have to transparently evaluate specific constraints across a few clear categories. Environmentally, they're assessing the impacts of seasonal variability, droughts, and even aquatic impingement, when aquatic life gets trapped in the cooling intakes. Financially and regulatorily, they have to look at how volatile water costs are and the very real risk of losing their water rates or permits. And finally, they've got to account for stakeholder perceptions. Because operating a thirsty plant in a water-stressed region, that can easily lead to direct competition with local communities or intense scrutiny from NGOs. So once those risks are identified, how do they actually fix them? Well, to hit their water management targets, companies usually follow a specific path. They move from basic operational efficiency, like installing closed-loop water recycling systems, all the way up to advanced product innovation. That might mean redesigning the packaging itself so the manufacturing process just inherently requires less water.
They also upgrade physical process equipment to protect local aquatic ecosystems. The standard is pretty strict here. It asks them to detail the start year, the target year, and the exact mechanisms they're going to use to get the job done. But as we know, sustainability is rarely a straight line. The standard has this really fascinating requirement. Companies have to disclose their life cycle trade-offs. Basically, they must admit if their water mitigation practices inadvertently create other environmental headaches. For instance, installing a massive state-of-the-art closed-loop water recycling facility is great. It might save millions of gallons of water. But it also might require a massive amount of electricity, which shoots the company's greenhouse gas emissions right up. The standard demands that companies explain why they chose a specific practice despite those trade-offs, ensuring investors get the complete, honest picture of the whole shebang. Section 4. Tracking Regulatory Noncompliance. Let's decode metric RTCP 140A 3.4.
Now we reach the regulatory teeth of the standard. It's one thing to have a nice strategy. It's another to actually follow the law. For any packaging manufacturer, the ideal target state is a massive 0. This metric demands the disclosure of the total number of incidents of non-compliance associated with water quality permits, standards, and regulations. A 0 means absolutely no incidents that resulted in formal government enforcement actions. That is the ultimate goal.
But what happens if a company strays from that 0? Well, this metric forces them to expose exactly what went wrong. Did they discharge hazardous substances like heavy metals or spent acids? Did they exceed their total maximum daily load, or TMDL, for a local river? Did their pretreatment systems fail? By mandating the disclosure of these formal enforcement actions, which can be anything from administrative penalties to full-blown judicial actions, the SASB standard shows investors exactly where a company is bleeding money. It exposes the legal expenses, the fines, and those emergency mitigation costs that stem from unmanaged wastewater.
And finally, Section 5, the bottom line. Focusing on operational resilience. Zooming out from the specific accounting metrics for a second, we have to ask, why does this actually matter to the market? As the standard itself highlights, efficient water management isn't just about regulatory box checking or feel-good PR. It is a core component of preserving revenue. When a packaging company reduces its water consumption through sheer efficiency, they directly lower their operating costs over time. And more importantly, they insulate themselves against the shock of sudden water supply shortages or new, aggressive environmental regulations. Fundamentally, it's about long-term operational resilience in a rapidly changing world. I'm going to leave you with this final thought. The next time you break down a cardboard box or crack open a beverage container, ask yourself about the unseen rivers, the local reservoirs, and the complex accounting matrices that were required to bring it right to your door. The hidden costs of our economy are all around us, provided you know exactly which metrics to look for. Thank you so much for joining me for this explainer, and keep questioning the footprint of the world around you.